Hello everyone, welcome to the 9th Global CAISPN call. We are talking today about open source spaceflight and applications to commercial space. CAISPN stands for the California International Spaceports Network. We are a network of startup and emerging spaceports and associated new space ventures. We are a supportive community to promote business, collaboration, and conversation between various new space businesses internationally. Tonight, our topic will be led by Mr. Aaron Harper of Issyroo Farms, open source expert. We will also have Mr. Matt Maier of Mach 30, advisor to the board. We will also have Mr. Jason Aspiotis of Crowd2Space, CEO and founder, and Mr. Gary Bickford of Integrated Space Analytics, CTO. To kick off, gentlemen, from left to right, please introduce yourselves, starting with Mr. Harper.
I'm Aaron Harper, Chief Technical Officer of Issyroo Farms and Lobos Heavy Technologies in Walsenburg, Colorado.
Mr. Bickford, go ahead, please.
Oh, okay. I'm Gary Bickford. I'm a partner at Space Finance Group and Chief Technical Officer at Integrated Space Analytics, producing the Integrated Space Plan.
All right. Mr. Aspiotis, please go ahead.
Thank you, Ethan. I'm Jason Aspiotis, the founder and CEO of Crowd2Space International. Crowd2Space, a new startup, considered a new space company, and we are considering ourselves a travel agency and crowdsourced bank for space travel.
All right, thank you. Mr. Maier, please go ahead.
Hi, I'm Matt Maier. Getting out of the Air Force. I've been in Mach 30 for a while, advising him now, and I'm founding Houser.com, which makes open source hardware easier.
All right, thank you, gentlemen. All right, Aaron, you have the floor. You have a presentation. Please go ahead.
Actually, a lot of this is just going to be screen share and talk. The first thing is, most people, when you hear open source, the question is, what is it? It's not a medical condition having to do with skin, but rather open source is a way that people share information. The sharing information is actually nothing new. Most people don't realize, but the ham radio community has been sharing hardware designs and procedures for quite some time. And also, in many cases, during wartime, specific designs are shared between manufacturers to step up the amount of manufacturing to meet demand. Example of that, I'm a combat veteran. The first M16 that they issued me had a Mattel sticker on or stamp on the side. That probably dates me pretty well, but the interesting thing there is that it was a design by another company, and in order to produce a sufficient number or to meet certain other criteria, other manufacturers were leveraged by giving them the design for the express purpose of producing it. As it applies today, open source has a few different definitions. Now, the first one was open source software, and that is the definition is visible now on the screen. The interesting part here is that you have several criteria. The free redistribution is one. License shall not restrict any party from selling or giving away the software. Source code must be included. No black boxes, nothing hidden. Because one of the strengths of open source is the fact that you have multiple eyes on the target. Nobody's going to put something nefarious in the source code without a couple thousand people looking at it and saying, "Wait a minute, what's this?" Derived works is allowed, as is the iterative developments. There's no discrimination against persons or groups. or fields of endeavor. The distribution of the license. Basically, all the rights attached must apply to all the people who the program is redistributed. It's not specific to a product. If they put something out open source and HP releases it, you can use it on a Dell. It does not restrict other software. Nobody's going to say, oh, you can only use mine. And the license must be technology neutral. That is, as close as possible to that. It shouldn't be predicated on any individual technology or style or of interface. Now, this is the software definition. The problem is bits and bytes are a little different than atoms. So here, a few years ago, it came up with a new definition for open hardware. Basically, it follows the same principle. If software is necessary to run the hardware, that is included and that is open source. Documentation is included. And one of the things that is interesting is if hardware is to be well documented, a lot of the design and early the early design information must be included as well, and that is a hard one. In actual implementation, that's probably one of the hardest things to comply with, because a lot of times we want to show our best product. We want to show the finished thing, not where we're falling on our face. The problem is that if we do that, those learning experiences that we had and didn't document or didn't share the documentation of are not provided, and anybody who does iteration might make the same mistake. Open source software and open source hardware are both about not reinventing the wheel. So if we have a learning experience, sharing that learning experience is critical. Again, derived works are allowed. Free redistribution of the design, not necessarily the device, is permitted. Things should be attributed. It's just like writing a paper for a college level or beyond paper. Is you have to attribute your sources. If you don't, it's plagiarism. Similarly, grabbing somebody's open source hardware or software and changing a few things at the top, branding it with your name and saying it's yours, that's plagiarism as well. Number 7 and number 8 are no discrimination against persons, groups, or against fields of endeavor. This is where open source runs into some problems. Open source hardware runs into some problems with the law, and we'll get to that in just a second. But essentially, if there's any kind of hardware being made, they cannot say you can't use it because of your ethnicity, because you're doing something slightly different, or in some cases because you're in a different country. If it's shared, period. The license, again, must not be specific to a product, must not restrict other hardware or software, must be technology neutral. And I should also point out that my company is, we're founding members of the Open Source Hardware Association, and we've been signatories of the open source hardware definition since while it was being developed. So it's sort of near and dear to my heart here. Just got to make sure I explain all the connections. Where things get interesting is when you apply open source hardware to specific fields of endeavor such as aerospace. Ironically, a rocket looks a lot like a missile. Works the same way too. So if you create certain things, they require the U.S. government, both State Department and Commerce and the Treasury Department, each have restrictions on what can be shared and with whom. True and full open source in aerospace, in every area of aerospace, is currently not attainable. We can't do that and comply with export control laws. The Treasury has OFAC lists that say you cannot share it with that person. We have technology embargoes in place with certain countries. ITAR raises its ugly head, the International Arms Controls, which is administered by the State Department. And then you have the Commerce Department's rules, the Export Administration Regulations, which determine what you can share with whom and certain criteria. It has to, it cannot go beyond this or so on. The point of that is, quite frankly, making sure that certain bad people don't get technology that enables them to do really, really bad things. That's it in a nutshell. Unfortunately, it's necessary in this day and age, but this still gives us a large area where open source can be used in aerospace. One example is in spacesuits. Ethan and I were developing under a DARPA contract a mechanical counterpressure spacesuit. Much of the development was done under the previous ITAR regulations. Now, a lot of one of the joys of living in this day and age is that export control, which was static for a long time, is under review. And one of the changes that happened is a lot of things got freed up. Things like spacesuits used to be part of ITAR, and if you had a spacesuit, it was considered a flight suit for high altitude spacecraft or aircraft such as the SR-71. Therefore, it was of strategic vital importance to the U.S. national security. Therefore, not shared. Well, times they change, and under export control reform, spacesuits are now considered under the EAR, under Commerce, under 9A515, which is a type of spacecraft. The suit basically being sort of a pressure hull, which means that it can be shared with certain restrictions. We are still not quite open, but we're getting there. We've made significant progress. The one thing that I want to point out here is that while open source cannot be fully and completely implemented in space, in space hardware, it is vitally important that we take what we can and share what we can and open what we can. Because when something goes wrong, if your VCR goes on the fritz, I'm dating myself again, if your DVD player goes on the fritz, generally speaking, you either send it into the shop or go down to Walmart, buy yourself a new one, and grouse and grumble about how you wasted money. If something goes wrong in a spacecraft, if you have time to fix it, you don't want to have to call the manufacturer. Documentation needs to be provided, and needs to be provided not only to the technicians who tell the monkey what to do. They've got to be able to be provided to the person doing the work. You know, we put engineers in space for a reason, and it's about time they get their college credit. The difficulty, though, is if it's a closed source, black box sort of arrangement. How are they supposed to fix something other than swapping a box which they don't have? You know, do they have a spare part? Great. If they do, wonderful. If they don't, you might need to do some kind of repair, and understanding how it works and having the documentation on tap at some level will help. And if that saves a life, just one life, that's worth it. Open source hardware, however, has got sort of a bad reputation about not being able to make money with. That's because everybody thinks you're giving away the farm. You're not. When you release the documentation, releasing the CAD files about how to make it, releasing releasing the instructions, build sheet, parts breakdown, the whole thing. That doesn't mean somebody else wants to build it. The truth of the matter is, most people, if they do build something, they are either scratching an itch, so to speak. You know, they really want to build something and have the experience of building it, which is either they're scratching an itch and it is a need of theirs, or the other one is that it is a curiosity thing, and they're trying to learn from it. As an employer, why would you prevent a person from learning about your technology unless your technology was easy to duplicate? I mean, you're not going to create it unless your product is so simple anyone can build it. You can't expect people to steal your idea and then go and make a production line and be ready to challenge you as the incumbent business. The way to stay, that's the first thing. The second one is the way to stay ahead of this curve is innovation. You know, a friend of mine who runs an electronics shop here in Colorado, who you may have heard of, Nathan Sato from SparkFun Electronics, did a TED Talk in Boulder about how open source actually works as far as hardware and as far as selling. The problem is he's got 6 weeks between the time he publicly releases something and the time that it's copied in Taiwan, China, wherever. He doesn't lose money and he doesn't lose sleep about that, though, because he has people to constantly iterate, constantly improve, constantly innovate, and create new products. He doesn't use it as a money machine where he cranks out the same thing every day and people buy that same thing. They go to SparkFun to buy components, not because they're the cheapest. You want cheap, you go on eBay. Because you want the latest thing, something that's got more features than the old copy. You also do it for support. If something breaks or something doesn't quite work the way you thought it did on the electronic component you bought, if you bought it on eBay, yeah, good luck with support. If you buy it from SparkFun or Adafruit, there are people on the phone who will help you. Well, you know, their specific job is to answer questions and help you integrate their product into yours. And that is the value add. The value add is innovation, and the second value add is support. And another open source company, this time software, is Red Hat. They cut their teeth not on providing any different code than any other. If you want to have Red Hat, the latest and greatest, all you have to do is get Fedora. It's a differently branded product, which is exactly the same. Where their business model helps is in support contracts, as well as support by by the incident, and also in helping you integrate your product and make it run under Red Hat smoothly and efficiently. That's why you would buy Red Hat versus get something for free. But essentially, in aerospace, we're looking at pretty much the same thing. In open hardware, with a lot of people, you can innovate very quickly. A lot of eyes on the project. Catching bugs is fairly trivial. In fact, there's a there's a law that they claim. It's called Linus's Law, named after Linus Torvalds, the originator of the Linux operating system, which is open source. And that is with many eyes on the code, the problem becomes trivial. All bugs become trivial. So in open source hardware, in aerospace, if you want something that will test well the first time, rather than have 5 people working together, sort of, and all closeted with their own source code, and nobody's sharing anything, even between teams, other than giving specs of the closed source modules that they hand out. Having an open source group who looks at the code, reviews the code, makes corrections, and submits them will result in a more functional product sooner. Likewise with hardware, if you've got several people working together, and one of the projects that we had, we worked on with using the same technology, using Google Hangouts, and that was a very interesting experience. The work went much quicker. It allowed people to supervise and to compare notes and to do a simultaneous build in 2 places to make sure the instructions were clear and were able to be followed. The result is that iterations happen quicker, innovations happen much more often because more people are involved, and this is the value add once again. And as far as support, you can gain your support from both the manufacturer as well as the local communities. For example, a lot of companies, for one particular example is the the network hardware company Ubiquiti. They don't have a support staff anymore. They don't need one. Their issues are handled by their customers in basically a forum where the questions have usually already been answered. And this actually ends up being much quicker for the client, being able to search through the forums than staying on hold for 30 minutes to an hour trying to troubleshoot the problem for the 15th time. And this ends up boiling down into a much faster response, better support, and a much simpler structure when it comes, and savings when it comes to support, which boils down to a much lower cost of the product. You don't have to amortize the support and the payroll. In open source hardware, as applies to aerospace, it's the same thing. Your developers become your support. And this pulls people out of the equation and pulls variables out of the equation. It makes it much easier to talk to the guy that actually wrote it and find out what the hell's going on. So that's basically what I have. And at this point in time, I'd like to, open the floor into sort of a Q&A session.
Alrighty, thank you, everyone. Please use the Google Hangout question function to pose questions, and I will accordingly address them to the audience, to the panel.
And actually, some discussion among the panel would be good too.
Kind of touching on a little something you had mentioned earlier, Aaron, but two issues I want to ask the panel about. Number one, how does open source work as a business premise, especially when it comes to managing profits, product quality, and IP? What is the opinion of the three of you, Jason, Matt, and Gary, in terms of how open source would incorporate to your respective businesses, because you have open aspects within what you guys are aiming to do?
I could speak to that a little bit. I've been in the software business and systems business for many years, and back in the 80s, you couldn't patent software at all, and we all got used to the idea that we're all going to share everything. If you didn't want to, and copyrights were ineffective, so the only way to protect software at that time, if you really wanted to, was to keep it as a trade secret. And most of the internet was constructed in using open source. So the advent of patenting software was a major disaster, I would say. And if you think about almost all of the most seminal advances in software were done back in the day when it was open. Imagine if Tim Berners-Lee had patented the web concept.
Yep.
We wouldn't be here. And I think as far as in space, especially with a new market like this, where you have a lot of new companies starting up and they have to work together, it's going to be very important, as Aaron suggested, that if you're out in space, there's two vehicles. You want those two vehicles to be able to mate and to be able to move from one to the other. If you haven't open sourced the design of the hatch, it's going to be a hard time. I'm not sure how long I can breathe in vacuum.
Actually, interestingly enough, there was a large amount of discussion, and I'm going to date myself again. There is a large amount of discussion in the Apollo-Soyuz mission. That was right after the last Apollo. I'm thinking 1972, where they linked up an Apollo capsule and a Soyuz as sort of an international handshake. And imagine trying to tell the Russians at that point in time how your hatch worked. Now we're talking about pretty much the hottest part of the Cold War. Yeah, that was interesting. Gary, you're muted, buddy.
There we go. Yeah, I pushed the wrong button. Yeah, I can't imagine that discussion amongst the engineers at the time. Because as you said, those were weapons at the time, and it's like a hatch is one thing that's probably the most amenable to discussion.
Yeah.
You know, rocket nozzles is probably not one that they were talking about.
Probably not. Even though in this crazy world we live in, American rockets are now using Russian engines. So, right, here we are.
So I have a couple of comments to your question, Ethan. Question being, how do you structure an aerospace company or a for-profit aerospace company that utilizes open source technology for space? And I completely agree with the panel and the speaker and Gary that space is a tough problem, and open source is definitely a very, very good solution because we require as much intellectual capacity to challenge and find solutions to the challenges when it comes to space technology and the issues. But at the same time, at the advent of blockchain and remuneration type technologies, it doesn't have to be that we completely forego any sort of licensing and transfer of value as a function of technology development via crowdsourcing and open source. I strongly believe that the patent system is faulty and probably not applicable, and will produce issues if someone or institutions try to adopt it for open source technology. But utilizing blockchain or remuneration to keep track of tech transfer and publicly open ledgers to see what tech transfers have occurred or are occurring, and what leads to what developments or what profits can lead to substantial profit sharing down the stream for people who actually did the work in the first place. So I do think there's a business case to be made for open source. It's not business as usual, but it's definitely a new type of business that I foresee being somewhat profitable for the, I guess, parent company. And I guess to my last comment about a parent company, you will still require a system engineering or a system architect core, which could be a person or several people that are kind of overseeing or managing a crowdsourced project in aerospace. You can't get away with not having that central architect that's going to be massaging the system into place and assigning and figuring out requirements at the top level. So that's my commentary for that question.
Quick aside to you, Jason, when you made mention of new way of doing business, do essentially, as I understood it, could you detail a little more what you mean when you say take a blockchain and utilize it to track who uses the technology to develop what? I'm a bit of a lay person when it comes to these terms, so if you may please explain what a blockchain is and what it does.
Sure. So I mean, in the most relevant sense, Bitcoin is a very good example of that. And blockchain and crypto has been around for several years now when it comes to currencies. I think there's definitely application for those basic principles when it comes to technology. So let's say I'm John Smith and I develop a component for a hatch for an aircraft. And this component provides a 2x performance increase as compared to other components that do the same job for that specific space hatch. And some company 10 years down the road wants to use that technology to go commercialize for future space missions, both government and private. This component was developed for future missions. The blockchain allows this company and also the person who invented the technology in the first place to keep track of how these transactions occur as a function of time, as a function of technology insertions. And so that level of public ledger and exposure and transparency, I believe, helps with making sure people get recognized and at some capacity get rewarded, even if it's 10 years down the road, without going down the path of difficult and hard to maneuver patents and licenses and royalty structures that exist right now.
Understood. So, as I understand it, that means that I could make a publication in the open on the net, saying, "Here's my design for a certain rocket motor," and just by tracing the blockchain, just by tracing who uses it, I can still retain original credit or original authorship of it and therefore gain credit. And as I understand what you're saying, that credit is what turns back to me as profitability for that publication.
In theory, correct. And no doubt there's a lot of people in the industry that don't really do what we do to make money. But whether it's recognition, credit, or combination of both, and some monetary compensation, I think that technology can definitely be used for exactly what you described, Ethan.
Yeah. When you say monetary compensation, does that mean that I'm asking, if you're going to use this product, pay me a royalty, or is it more of the sense of give me a donation to continue to support this work, such as what is done in the open software community now?
I mean, in theory, the blockchain should be able to trace every contribution from a technology perspective to every last dollar of profit made from that technology. Now, let's not get ahead of ourselves. It's not easy because there's going to be a certain consideration of who adopts this kind of level of consideration for blockchain usage in this context, and it's not, as I mentioned, easy to trace technology in to dollars out 10, 20 years down the road. But now we have this technology, I believe we should start considering how to best use it in the application of aerospace and future commercial space.
I have a follow-up question for Jason. You mentioned that you believe that the patent system is at best non-functional and probably broken. I have some examples of that, but I'd like to hear your justification for that.
It takes too long. If that's the only thing I can say, I mean, that's important enough.
Right.
So it takes too long, and it is kind of cumbersome in just being able to figure out what's been done, relevance of what's been done, prior art. All the intricacies of patents are quite, let's say, interesting. So I wouldn't want to see those intricacies be a barrier to some sort of incentive in the monetary sense for future designers, future architects, future aspiring engineers that want to make a difference in the space industry, but would like to make a living out of it. And so if we're working on the premise that crowdsourcing, both for hardware and software and maybe systems in space, is going to be a big part of the future, we have to figure out how to incentivize that future. And I think blockchain remuneration is a very, very good incentive for that future, and patents are just too cumbersome and maybe even a natural barrier for people to even consider that.
Right.
So in a way, it becomes a new way to manage IP. It's the next generation to take a hold of the digital age and the sharing of information there. Quick question from Mr. Dahlstrom in the audience. He's asking, blockchain tracking. You mean you could not use the design without the blockchain? This is an amazing idea. Tell us more about basically the control of the blockchain that Mr. Dahlstrom is asking of.
So I may have dug myself into a hole because I can't answer everything about blockchain. I have to admit, I will need a little bit more elaboration on that question, please. Blockchain tracking, what do you mean, sir?
Let's see if Mr. Dahlstrom is typing.
Absolutely.
I think while waiting for Mr. Dahlstrom to submit another question, let's go on to another question here from him.
Okay.
Mr. Dahlstrom is also asking, question, are there any examples of complex systems of open source hardware?
So, yeah, I mean, there are. Well, it depends on how closely you define open source. So the thing that people tend to forget in conversation is that open source is a legal standard. So technically something isn't open source unless you've applied an open source license to it. but the principles of open source have been used forever, unofficially. So, for example, plumbing is basically a giant open source hardware system, in that all the standards, all the manufacturing processes are available for anybody. Anyone can make PVC pipe if they want to. Anybody can make a pipe that interfaces with it, some new technology if they wanted to. And it actually helps. So all plumbing is basically a giant open source hardware system, which actually is a good way to remember sort of in the business sense, how do you make money off of open source? A really common separation is the difference between infrastructure and then some differentiation on top of it. So like all the plumbing is open source and open standards. Anybody can make it, anybody can sell it, whatever. And then the faucets are all like really pretty and separate and special things. Like if you want a certain faucet, well, they'll probably have a design patent on it. You can only get it from one trademarked producer. So the faucets are where they differentiate. And you can charge a ton for a faucet, or you can get a little dinky faucet that just does the job. It's effectively, part of the infrastructure too, which is, you see a lot of in software. Like you'll have the net, which is the plumbing, the infrastructure, and then people build their apps on top of it. And then the differentiated app has tons of value, which you can charge for.
I wanted to come back to the blockchain thing, although it's a little bit outside the open source hardware question, but it's the blockchain principles and methodology is going to be, I believe, going to be an essential element of contracts in an interplanetary space environment, because it's the only way, it's an ideal way, I guess, in some sense, of provably conducting a transaction across a million miles of space, and being able to prove that somebody did sign something with their proven signature. There is a disadvantage, which is at present a blockchain transaction takes roughly 1,000 times as much energy as a Visa transaction in terms of computational. A computer is basically a big heater. So every blockchain transaction is generating 1,000 times as much heat as a Visa transaction. That we may find ways to deal with that. And another very closely related problem is that at present the blockchains cannot be taken large enough to handle the level of transactions that even today's Visa transactions are. There's something on the order of a billion Visa transactions a day, and that would take more computers than we have any likelihood of assigning to it to run blockchains at that level. So blockchains are, on one hand, very important, I think, for space, and not just for the reasons that Jason brought out, but at the same time, they're also going to be a critical impediment.
So yeah, blockchains are going to be really interesting. One of the things I think will be useful for open source hardware is it goes back to ITAR, where the idea is some people aren't allowed to have certain things. You don't want to give so-and-so some missile technology because they might use it, and then it would cancel out your missile technology. So there are rules, and like ITAR always has like a person who's responsible for it, like named person. It's your problem if anybody does anything wrong. So there's this thing called distributed autonomous corporations, which use the blockchain, and instead of just putting like financial transactions into it, you put the code into it, and that way everybody can effectively buy coins or shares of this code, and everybody can audit the code because it's in the blockchain, so you can never change the code secretly. And then the corporation just runs according to that publicly available code. So if you invest in it by buying coins, effectively giving it capital, and then the code, which is public and unchangeable, runs whatever its script is that you think is a good idea using the capital you gave it, and if the corporation makes a profit, it'll increase in value, and your coin will increase in value. So you'll effectively be an investor like any other corporation. But no human gets to make a decision about what the corporation does. So if you had, once we have some politicians who maybe grew up with smartphones or something. If you had a distributed autonomous corporation and it was in charge of potentially sensitive hardware that you might be worried about somebody like releasing or something, or there'd be a secret agent or something like that. If it was a public code that could be audited to guarantee at least that code would never make any wrong decisions or lie, cheat, or steal or anything with that information, then you could entrust sensitive technology to the automatic corporation and not to a person. So it might be possible to share it because you wouldn't have to worry about people, turning on each other, being untrustworthy stuff.
So you're saying, Matt, that you might, in a sense, that the corporate entity would be able to know some, let's say, some secret missile design, even though no party in the corporation actually knows it. That's, basically the corporation is the secret is an emergent process, emergent result of the system, which is the corporation. It's sort of like, by analogy, there's no cell in our brain that knows a fact, but the brain as a whole does know the fact.
Yeah, I'm not sure how distributed the actual information itself would be. That was a secret, but you could, for example, have the information always encrypted on disk and always encrypted in between transfer between like an engineer and storage or whatever, or a manufacturer or something like that, so that no human ever gets to see it except the person who's contracted to be responsible or something, or trackable. And if you had a human group, a human might steal it, or they might decrypt it and like sell it to China or something. So if the corporation's code that runs everything was public and everyone could audit it, you would know that you'll have to brute force it, right? Just like any other hack. No one will ever release it, voluntarily, because it's under the control of incorruptible code.
In another aspect of, I have another job which is helping out with a company called the Drive Trust Alliance that's working on some stuff that's closely related to that. It's the encrypted hard drives, the self-encrypting drives that Apple and the FBI are talking about right now, one of the things you can do with the self-encrypting drives and with the software that the Drive Trust Alliance is working with the drive manufacturers on is the ability to split the key, the encryption key, into multiple pieces so that no one person has the entire key. And so they all have to participate and free and open their piece of the key in order for the information to be released. So, Aaron, on this, are any of the space companies like the parts companies, are any of those actively working with the open source hardware paradigm now?
Not to my knowledge, though we did have an interesting event. I made a small satellite ground station to work with a specific CubeSat. The ground station was supposed to be a payoff for folks that supported it on Kickstarter. Well, interestingly enough, the Navy got interested in it because the ground station was apparently much smaller than anything that they had yet considered. And I probably spent 40 minutes trying to explain that they could have the design for free, but it could not be exclusively theirs. The bottom line here is that they I don't think a lot of the folks understand open source hardware and what it actually means. but but that also means that they don't understand the benefits to them. So there's a lot of opportunity here.
You know, that's interesting because oh, go ahead. I guess that's an echo.
Aaron, you might want to mute. You're getting a feedback loop.
Okay, not a problem.
It's interesting because NASA's charter requires that everything that they do be open source unless it's secret. I got to step away for just a second. I'll be right back.
Yeah, it's interesting that NASA's charter would be part of that, and that actually makes a lot of sense. The interesting part is that there was a U.S. government agency who right now their name is not exactly that I won't say they're public enemy number one, but they have fallen somewhat out of disfavor with John Q. Public. But NSA back in I think they started the project in '95 or '96 and continued through 2002. They developed parts of the Linux kernel and enhanced its security, and that became Security Enhanced Linux, or SE Linux. It became the de facto standard of secure computing, in the Unix world, and certainly brought things to the next level. A lot of people would be worried about, they're probably inserted some code to spy on it. Well, the code is open. People reviewed the code, and thus it became a great way to expand the offering of what Linux did as far as what it could provide. And it was most open source software and hardware projects start as scratching an itch. Somebody somewhere has something they need done. So rather than have everybody reinvent the wheel, they share it, and other people with similar needs adopt it. And that's exactly what happened here, and I suspect that's what they're after with NASA, with their open source initiative.
Here's kind of Aaron, if you may mute, please.
Oh, sorry about that.
All right. Here's a question, as I'm understanding Mr. Dahlstrom's question, and from what has been discussed here about blockchains. And Matt, as I understood it, you said that a blockchain is a way to enable tracking of someone's software to ensure that, one, it has not been changed, tampered with, or otherwise. But from Mr. Dahlstrom's question, it seems that he's implying that a blockchain is a way that you could prevent someone from having unauthorized use of your design or your software where they cannot disconnect it from that blockchain. And therefore, is this a appreciable security feature that can potentially stop someone from stealing the software from the blockchain, or is it a way to keep that technology from being used outside of the blockchain?
If that was directed to me, if I'm understanding it, the way the blockchain works, by definition, it gives the same information to thousands of different people, and they all have to be able to confirm that everybody else has the same information. So the blockchain itself is like one hashed thing, so you know if it changed because you'll get a different hash out of it, to dramatically oversimplify it. But I don't know, maybe, like, could you do an encrypted blockchain, I guess, where it's encrypted before it's publicized and only a few people have the decryption codes, maybe? Regardless, the way the blockchain works is that, like, everybody has the same information, right? So yeah, if you put something in there, you're sharing it with thousands of people so that they can share it with each other and they can all simultaneously confirm that one thing is true, more or less. So if you put something in the blockchain, I think that's sort of the opposite of ensuring nobody could ever use it or take it out, because they could just like copy it from their copy of the ledger, I assume. There may be some clever thing in there that I haven't thought of or heard about.
Okay. Understood. So it's like you give me drawing for a specific CAD file for a specific thread on a specific pipe end, and that thing's blockchain to the various creators who built that thread. But if I just simply say, just take it in CAD, measure it out, and then just go to another CAD program and just copy out the whole design from raw CAD material, I essentially have a copy of that thing that's not attached to that blockchain, but then people are going to be asking, who made this design, and why is it not attached to my blockchain, is what they're going to notice very quickly. Is that correct? I mean, you haven't stopped me from using the design, but you have detected that I have made a copy outside of that chain.
That sounds right, but I'm not sure.
Okay. So yeah, I assume if you distributed a file through the blockchain, a big one like a CAD file, you could hash it, and everybody would have the hash and they'd have the file name and whatnot. So the only way, so if somebody else had a file and you wanted to test it, you could hash that file, and if you get the exact same result, then there's like a 1,000,000,000 to 1 chance that that's not the same file. But any change to that file will give you you'll never be able to get the same result.
Got it. Okay. So blockchain can't be used as a direct security feature to completely stop someone from using a design, but it does allow tracking.
Well, okay. So the courts is what would stop somebody from using a design. So that's what open source relies on copyright. So, and to a lesser extent patent. So if you could prove somebody is using the design you distributed in the blockchain, because the blockchain is a more or less perfect record, and their file hashes to the exact same thing, then I guess you could prove in court that they were using the thing that was distributed, that they didn't like make it themselves, because they'd never be able to hash the same way.
Okay, got it. Understood. Thank you, gentlemen. On to
so I had a thing about going back ways about the business aspect and how do you sort of make money and whatnot off of open source. Hardware specifically, before we move past it too far. So one thing that came out of the RepRap project that was reasonably well documented in Eric DeBrugen's thesis is that the RepRap project made 3D printers and everybody could make them. So over the course of the growth of the RepRap project, they showed more than an order of magnitude investment of time and money in terms of R&D and Q&A into the open source 3D printers than would have been possible if every employee of every additive manufacturing company in Europe tried to do the same thing. Like, so many people just did volunteer time on it and just contributed stuff that they thought was interesting, and that it just dwarfed the amount of research and Q&A that was done by the industry itself. And like, I think a lot of people don't really get that when they think about how can I make money off of open source hardware. It's like Nathan Seidel said, if you can move fast and you're all about like the next great thing and changing stuff, then you basically don't have to do R&D. You just have to do integration. Everybody else will do it for you, and all you have to do is sort of scoop it all up and make sure it works together for a minute, and then hand it out, and then do a Q&A on it. And then you just tweak a few things and fix it, and issue like 1.1, and at the same time you're working on 2.0 because everybody else is working on it. So you can just become like an integrator.
Yeah, but my understanding, in going back on what Aaron had mentioned about SparkFun, and Aaron and I had a chance to tour the organization back just earlier this summer, and Aaron, I recall you'd cited SparkFun as an example of where every design was open source, but what value they added was the fact that there was a support staff, there were people creating new items from these kits, and the fact that they had to, in order to maintain their profitable edge, they had to keep going ahead of that wave of innovation that follows after a new design is released, after an update is given. And therefore, we see one way of making business in open source is you release your product, but you associate it with services that make you your profit, ergo assembling of a kit and giving support. But the second example I've seen is when you take Tesla Motors. They open sourced the design of the Tesla charger and the supercharger, but for reasons that is essentially a loss leader that allows them to make sales of the car, which is where they've retained that as their IP and their respective sale. And I recall it. A friend of mine who had described it to me said that the reason for doing that is because if they just held on to the superchargers and the designs and the car itself, no one could purchase a Tesla because no one could build a supercharger, and the sale of a Tesla is enabled by the presence of one. In fact, I had a chance to tour Dallas Makerspace and saw that they had built one of the superchargers from the open source design as part of the initiative of where it was released, and put it on the map to say, we now have a Tesla supercharger here, all you Tesla owners come by. But going back to the conclusion, that's an example where we see open source is not necessarily your primary business, but it's something that allows you to contribute and enables your primary business to move forward.
You know, having been in the software startup industry for a long time, the open source, sharing information has been a critical element of success in each of these markets when they've been really young. When Sun was starting out, and when all these different companies were starting out, in an immature, high technology market. It's really important for the companies to share information, even though they're competing. And plus, I think there's a lot more geek influence, if you will, at that time. So that we like to share information with each other because that's sort of the socialism of the geek thing, of the intellectual socialism or something. I don't know. But so that's really important at startups. It's less important for mature industries, that's where I think the patent things start happening. But so I have a question for Aaron in particular, but I'll throw it out to everybody. Is there a place where, like open source designs, is there a repository where people can sort of go through the catalog and say, oh, that's what I'd like to do?
There are a few. One in particular that Ethan and Matt and I have all used is called Open Design Engine. And it is basically an adaptation of, let's see, it's Ruby, so it would be, what is the code base of ODE, Matt? Do you remember?
I think it was Redmine.
Redmine, that's the one. Yeah, it essentially what they've done is they've taken Redmine and moved it from being software-centric to something that is hardware-centric. Right now, I'm sharing on the screen the talk for Nathan Seidel regarding the open source. The link is there at the bottom, or you could search for how open hardware will take over the world. If you haven't seen it, it is worth your time. But Open Design Engine, I'm going to swing over here. There it is. Open Design Engine is a repository of all kinds of things, and most of it because the people that are developing it and are developing projects on it, most of them are aerospace related. We've got high altitude balloon project, that's the Far Horizons. We got electric furnace that's in development. There's the ground sphere CubeSat ground station. I wish they'd use a more current picture. That was like version 0.001. There's other projects out here, which some of them, I would say about half the projects are aerospace related. About half of them are not, but it's all open source hardware. And some of the projects are populated. Some of them are just placeholders for when people have time, whatever. But this is just one example. There are other areas where open hardware is put out. There's also repositories for 3D printed designs, which, if they are shared, they are open hardware. And there's a big brouhaha with Thingiverse, where somebody has basically grabbed it, harvested things off of Thingiverse and put them all on eBay. Well, as long as they say where they got it, you can't limit the use. But that is essentially the this in a nutshell. Yeah, there are, but there needs to be more. There always needs to be more.
I noticed in that list there were quite a few space-related projects, it looked like.
Yes, indeed. Open Design Engine was set up by an organization called Mach 30. They are a nonprofit dedicated to hastening ubiquitous spaceflight and making sure that we become a multiplanetary species within a reasonable amount of time. In order to facilitate that, one of their first projects was Open Design Engine, in order to, again, facilitate the open hardware design of aerospace hardware.
Cool.
I have a question for the panel, actually, and does anybody know of any studies that have been done on quantifying cost reductions to aerospace projects as a function of crowdsourcing?
Gary, isn't there a body of evidence for the software world in particular? Because I recall from our discussions on valuating business, you had spoken of what advantage a software company has to be open versus closed.
Geez, I don't remember it. I'm sure there's been studies done. I just don't recall right now. Sorry.
So when I was doing my master's like 3 or 4 years ago, I looked into almost that specifically. I looked into open source, and it could lower the cost of aerospace. That was my sort of thesis. And I didn't actually find any solid conclusions on the subject. I found like a couple papers that sort of talked about it, but they were all brand new from people in the open source hardware community, like Eric DeBrugen's thesis. And I can't remember her name right now. I'm blanking. But yeah, there's a more recent example from Dr. Pierce of MIT where he estimated the financial impact of open sourcing a piece of technology. So you might be able to flip that and say that, so he had a syringe pump, so it's like an automated syringe that would put out certain amounts of liquid with a robot, so you could do automated experiments. And he found that like one syringe pump was worth like millions of dollars to the world just because of how many people no longer had to buy really expensive syringe pumps. And so you could, I guess, flip that and say that if a syringe pump was part of a system and you could reduce the cost by this much, then that has an effect on the cost of the system if you did it to a bunch of different parts. And in theory, you should also be able to spread out and say if everybody else was trying to build it and it only costs this much to do, then all of their systems are reduced by a cumulative $1 million, I guess. It might even inspire more people to do it, which would increase it even more. You might be able to extend his real brief research.
Yeah, on my screen I've got it shared, Quantifying the Value of Open Source Hardware Development by Joshua M. Pierce.
Okay, because I recall you guys had published that some years back in Mach 30, and that was a very interesting read.
Yep. It was indeed. There is another measuring the value of open hardware design that's on opensource.com, which is a website supported by Red Hat, just to make sure all the affiliations are known.
There's also Eric DeBrugen's thesis on the RepRap project, which is actually a little bit dated now because the RepRap project is continued on after he finished up his paper. And I feel like it's safe to say that the RepRap project is the reason there is a consumer 3D printing market. And that market, the last thing I saw was it's worth like $3 billion or something. So that was because of one open source hardware design, spreading and growing and forking. And then all the people who did that. And it just gave everybody a new possibility.
And from the space perspective, we've now realized that I think that 3D printing of a variety of different kinds is going to be one of the chief enabling technologies for space habitation and space development. In fact, we were just talking about this yesterday with the planetary resources and 3D systems. They 3D printed. They took a piece of an asteroid, used vapor. They vaporized it into a powder, and then they fabricated a part. It's just a little widget out of asteroid material using a 3D printer. And then they have a 3D printer up on the International Space Station, which has shown that at least one kind of 3D printing works in microgravity. So we've now closed the loop of manufacturing using 3D printing in space. And at this point it's merely a matter of scaling and it's engineering details. At this point you could build a robot that goes to an asteroid, grabs a hold of the asteroid, starts using solar energy to vaporize the material and refine it, and then continues to actually print a truss maybe half a mile long out of that asteroid. You could actually build an arbitrary large object out of that material, which is basically steel.
Understood. Gentlemen, going back to the lineup of questions here, Mr. Dahlstrom asked this: what is the difference between a fully open source design and a design shared but only unlocked by invoking the blockchain mechanism? i.e., how do you know if Boeing wants to use your design versus their Indian Republic Guard, which is what ITAR prevents?
That's a good question. The way it would work is the same way you make sure that your Bitcoins stay with you. You have a key which unlocks a certain number of blocks of information. The problem stems though in the implementation, because unlike a cryptocurrency Bitcoin, we're dealing with large amounts of information with a hash rather than a finite length.
Mm-hmm. I mean, good old basic access rights information could go quite a long way if implemented as a hybrid solution to the blockchain. I mean, your bank accounts, the bank can access it, the Fed can access it, but nobody else can access it. Very, very rudimental, naive example. But in the case of the Boeing example, there's no reason why Boeing couldn't control who gets to access their information. And so tiered information sharing is totally a possible hybrid scenario of open source plus protected source that still benefits the whole. And something I've been advocating in the confines of our company and meetings I've been discussing open source and how to apply open source to aerospace is sometimes you don't need to be full disclosure about everything you're doing. If you're simply saying, I'm working on next generation ion propulsion system without any details, that's very, very beneficial to the world without giving any details that may become counter in terms of geopolitical issues with sharing too much information. So I think a hybrid approach, as the gentleman mentioned, is perfect. And absolutely, there has to be some level of control from the creator of information to how much they want to disseminate that information to the rest of the world.
Yeah, I agree that like, that's the reason that open source is a legal standard is you're basically saying I have copyright, you're not allowed to use it at all, but I will give you these specific rights as long as you respect some rules. And I think there's like a caveat though in that, especially with everything being digitized, like we're saying, hey, let's digitize the information and share it. It's more a matter of like intention that somebody doesn't have that information. Like I'm in the military and they did a background check on me, and odds are my background check is now public, or in a certain circle it's public, because government put access controls on it and it didn't matter. Somebody got all that information and took it out anyways. And you would imagine that they would have a pretty strong interest in making sure their giant background database didn't get hacked, because it's full of information that was specifically collected so people couldn't be blackmailed. But now the information is public, so now they can be blackmailed. It's like they have a great incentive not to let that happen, still let it happen. So access controls on information are only going to be as good as people's intention to not want that information. So I think if you operate under the assumption that people will have the information, you want a system in which they don't want to abuse that information because they have other things that they can do with it. Like if you're all coupled by economics, then you don't want to blow each other up, because then your economy would crash.
I have a copy of your background investigation if you want to see it. No, I'm kidding.
I will just say as an aside that the personnel records system there, that the database that Matt's talking about, that system violated one of the fundamental principles of security in the military, which is the need to know. You know, that system should not have been all in one integrated system. It should have been in a series of silos with ways to get between them, so that if you get into one part, you can get in. Maybe you would have given up some parts of it, but so there were some serious mistakes made there. And in fact, my associate, who is one of the people in that area, he says basically they should be tried for treason.
Yeah, it is exactly the same as Snowden, right? You would assume that if anybody was good at digital security, it would be the NSA, right? Turns out no, the NSA is not good at digital security, at least no better than anybody else, because they don't even know what he took, right? Like even after they knew he did it, they still couldn't audit what he actually took. So the people who are supposed to, like, their name is digital security stuff, even they did all sorts of stuff wrong and got lazy and complacent and just, schlubby about it. So I think it's just assume that your info is going to get out there if it's at all valuable. If anybody's interested in it, they're going to get it sooner or later, probably sooner.
Well, one of the fundamental principles of civilization is that we have to be able to trust each other more than distrust. Otherwise, we wouldn't even have a civilization. So, this is a dance that we're always going to have to be dancing. We have to allow people. When's the last time you backed up your computer, and are you using the encrypted hard drive? You and I don't feel that it's worth our time, whatever time it takes, and the complexity of maintaining it, to do some of those things that are probably essential if we really want to protect ourselves. But people just we don't really want to give up that much of our mental effort to protect against something that's really not going to make that big a difference, we hope. But civilization is basically depending on everybody around us to not decide suddenly to see how many cars they're going to hit on the freeway before somebody stops them.
Yeah.
So I like to put forward a very, very substantial precedent to everything we're talking about in history. And we all agree space is hard, space is important. So no point debating that. But if you go back a few hundred years to the beginnings of the exploration and economic development of the New World, it was the countries and nations that explored the, I guess, historic sense of open source that were the most successful in exploring the world and developing an economic sense. And the primary example, the Dutch. So where the Spanish were secretive about what they were doing, where they were gathering resources, et cetera, et cetera, the Dutch were open about everything, especially when it came to maps of where to go, where to find XYZ resources, where to not to go, where there are indigenous populations that are hostile, where there are indigenous populations that are friendly, all the above, right? So in a equal sense, what we're seeking is kind of a repeat of that, where information is an enabler to advancement for everyone. And where we all profit is via that advancement in the end. Yeah. So the means of sharing information is definitely a means towards a very common yet advantageous and profitable end. And all we have to do is look back a few centuries to the Dutch, and there you go, success story.
I have one question about the Dutch, though, based on my understanding of history. But the primary basis of why the Dutch shared that information was because, to begin with, they were a nation that majority traded in exports with other European nations, and therefore, for their economy to survive, they need to let everyone know, yes, we're trading, but here's where it's at. And in a way, my understanding of the secretiveness of your information versus not is usually correlates to how big your organization is. The bigger you are, the more chances you have to talk with yourselves, and therefore there is really no need to share anything externally. But if you're essentially, as Holland was, essentially a small nation that relied on technology and trade to be equivalent in power and economy of the much larger nations during that era of European colonization and mercantilism, they needed to trade outside, because trading within themselves was not a viable or sustainable option. Is that a logical statement, and does that make sense to say that your disposition drives whether you can be open or what you do with your information?
So absolutely, but again, what you're saying, Ethan, is that information is key. They disseminate information because they value the fact that the more information they're disseminated, the more profitable they end up being for themselves, but also more beneficial for their trading partners. So in the same sense, knowledge and technology and capability, if we just say it's a commodity and we're just trading it amongst ourselves, whether we are Americans, British, South Africa, Australia, Japanese, Chinese, we're all trading capability for the betterment of the entire economy, global economy. And so that's one of the advantages of open source technology in the context of space. Because we can fight about, oh, well, I want to keep this capability secret. By the way, people will find out about it anyway down the road. Or we can be open source about pretty much most of everything. I mean, I'm sure there's going to be always restrictions of what's open source and what's not. But the end goal, which is global scale advancements in economic development space, is beneficial for all. Now, that's definitely an altruistic statement. Full disclosure that, in theory, it sounds perfect, but the practice of it is going to be the challenging part. But at least in theory, it works.
Yeah.
Go
ahead, Matt.
Yeah, I mean, I really couldn't agree with that more. That's sort of the point of the startup that I'm starting, is the idea that if one person knows something or how to do something, everybody else in the world should know how to do it too. I mean, they will eventually anyways. So if you do it fast, then you get things faster. Like an example to bounce backwards a little bit is that the chicken and egg problem with Tesla and the supercharger stations. It's hard to have an electric vehicle without places to recharge it. You have a chicken and egg problem, and those happen in technology pretty often. But you don't really have a chicken and egg problem if all the information is open, because you don't need one actor to front the entire investment for the whole integrated system. Instead, each person kind of fronts a little bit of it, and you get a lot more resources invested in the whole system piecemeal, and it all comes together rather than having to have one person decide to take that huge risk and invest. If it's distributed, then it's distributed. Like, you can get a little bit from everybody, like the crowdfunding thing. If everybody puts in $10, but you have thousands of them, then you can get a useful pile of stuff to work with.
So at the end of the day, Ethan, what's rewarded in this paradigm is not withholding information and, I guess the phrase is, milking it for what it's worth, but being open about information and making a profit via a smaller share of a much larger economy.
Yeah, and I
Understood.
sorry. I think something that I came around to after figuring out something on my own is that what a lot of people aren't calculating in is that syringe pump thing, and that by open sourcing one design, Dr. Pierce and his team contributed millions of dollars to the world, in the sense that people don't need millions of dollars. There's no need for the transaction anymore, because the information is freely available. They can do it themselves. So in a sense, he reduced the need for millions of dollars across the entire world. And if you keep doing that, then everybody's better off, because you just don't need as much transactions happening. You already have what you need because the information is available. You can do it yourself or get somebody else to do it. And you don't, like, there was this thing with the Open Prosthetic Project where there was a prosthetic hand that was like $20,000, and some guy 3D printed one that was like $20. And that means that somebody was charging crippled children $20,000 for a $20 piece of hardware. So all they had to do was make the information on here's how you make this simple prosthetic hand available, and now everybody can make it for $20 instead of having to cobble together $20,000.
There is also another corollary to that about the prosthetic is children grow, and a child which requires a prosthetic at age 5, by the time they hit age 12, they're going to need another prosthetic. So you're not hitting them for 20,000. You're hitting them for 20,000 again and again and again. You're essentially printing money.
Now, that'd be a trick.
Yeah, wouldn't it though? But folks are doing it. Speaking of tricks, there's a your friend was talking about how it was the information leak was treasonous and about equal to what Snowden did. And that you should have the information siloed on need to know. You can have a staged approach. I've got information on my website that I would want everybody in the world to know. I've got information on private servers that I really don't want people to know. But if there's a breach, yeah, okay, it's not going to really cause any problems. I've got other information. We do some defense work. We do some work with with private companies with IP that is definitely not open, and I have some designs that are export controlled and really would not be good to share. That doesn't go on it goes on a server, but more specifically, it goes in a server. The hard drive, when I'm done, is removed and locked in a safe. Good luck.
Is that a self-encrypting drive?
No, it is not. If it was a self-encrypting drive, it probably wouldn't need to go in a safe.
That's true. Yeah. This company I work with, that's what one of the things they do. They also have systems to separate. So they have for your username and password for logging into things.
Mhm.
It turns out there's some really good reasons why these websites and companies online and so forth should not have the username and the passwords should not even be in the same company, much less the same servers, much less the same database.
Right. It needs to be held in escrow.
Yeah, so they run a separate basically software as a service that allows you to log in through the web, and the place you're logging into doesn't have your password.
Right.
There's no way they can give it away. That would have saved Target about $120 million.
Well, how that's possible using old technology. How long has Kerberos been around?
Mm-hmm.
Yeah, that's another standard that is open. The secrets and the keys are not, but the technology is.
Except for the Microsoft version.
Well, that's them.
So I have a question, sort of a more general question. I think mostly for Aaron. I think, but it's worthy of discussion. Which is, you may be familiar with the integrated space plan and what we're doing. We're doing the online stuff to generate, data, a central repository for information. How can we, for example, help support the open source hardware for in the space context?
Create a tool. Help us scratch the itch.
What kind of a tool?
Well, the first thing, you got to look at how people are going to use it. Right now, there's not a whole lot of open source hardware as far as aerospace or open source software for aerospace out there. The easiest tool that you could do is a development environment. We're not talking software. We're talking about hardware. This would be a way to integrate videos on how-tos, plugins for the sort of a picture library, the ability to create documents on the fly, because a lot of the work in doing open source is documenting. And like I said in my little piece, it's more important to document your failures. I'll go as far as to say it is more important to document your failures than it is to document your success. It's also more time-consuming. It's also embarrassing. I'll give you an example. In order to build the satellite ground station, I had to develop a way to do a solder mask that could be duplicated by other people. Everybody in their duck has got the open source version of taking a toaster oven and turning it into a reflow oven. Yeah, it works pretty good. I personally have a commercial reflow oven, but that's just me. But I needed something that people could duplicate. The reflow oven out of the toaster oven, that's already out there. That's open source hardware. What wasn't out there was a way to build the surface mount circuit. And in this particular case, it was a 900 megahertz centered preamp, 40 dB of gain, very low noise, so that it could pick out that signal right out of the noise floor and apply it to the software-defined radio. The software-defined radio was easy. That's available. It's closed source, closed hardware, but it's commercially available. So I cheated a little. But what wasn't available was the preamp. So I had to develop a way for a person to build the preamp. Where I went wrong was I needed a way for folks to be able to apply solder paste to a PC board and be able to develop the mask to do so. Well, after a long time, I figured out that a standard soft drink can, if you are able to cut the holes to apply the solder paste is exactly the right thickness to give the exact right amount of solder paste on a pad. Now that was a wonderful coincidence, because anybody can cut up a soda can and work with the aluminum. Where I went wrong is that when it comes time to cut out all the little tiny holes, the best way to do it was etching.
Oh.
Now, etching, again, is not a really terribly hard prospect. You have, in my case, it was a combination of 3% hydrogen peroxide, the stuff you get at a drugstore, and for wound treatment and topical use, and muriatic acid, which you can get from a hardware store in order to work with pools to adjust the pH or get rid of hard water, stains and scale. I understood from a gentleman that the correct amount, the correct proportion is 3-to-1.
Which way?
Exactly. He failed to mention that. And I figured, okay, since I'm etching here, it's probably 3 parts muriatic acid, 1 part hydrogen peroxide, because we're just after the ion, right? The resulting reaction was impressive.
I want to try that.
Yeah, it's great. Actually, sometime I highly recommend it, but make sure it's outside, which mine wasn't. Make sure that you're wearing some kind of gloves, because if it splashes, it's pretty impressive. But take a Coke can, throw it into muriatic acid and hydrogen peroxide. It's very impressive. But what I did is the system uses a laser printed mask which you apply using heat. I used a clothes iron because, again, this needs to be duplicatable in this particular case especially. I used a clothes iron to transfer the toner, soaked it in water, removed the paper carefully, scrubbed off all the remaining paper, the pulp that was on there. Once it was clean, I took it, used masking tape to go around the edge so I didn't end up with something coming in from the side. And when I was done, I threw the can in the blank into the muriatic acid. One violent boil later, I figured this is not quite the way he described it, and I went in with a pair of tongs to pull it out. What I grabbed was the toner. The aluminum was gone. Yeah, and I documented the living hell out of that because, number one, I thought it was cool, and number two, this is something that people needed to know. It's a vital piece of information in order to be successful, and not reinvent the wheel, because reinventing the wheel is redoing all the mistakes. The correct amount, the correct amount is 3 parts hydrogen peroxide, 1 part muriatic acid, and it's a nice gentle thing, and it will etch completely through the can in about 20 minutes.
That's cool.
Yeah.
This is probably also a lesson of run a test batch first.
Right. Now where it's important to share is my significant other is an asthmatic. And when you do this, the reason I say do this outside, and I didn't, what is released is hydrogen gas and chlorine gas in grand and glorious quantities.
A lovely combination.
Oh yeah, especially for somebody with asthma.
Toss some ammonia in there just to make it more interesting.
Oh sure, yeah, that would probably be the death knell of her. Yep. But yeah, I let's just say I slept on the couch that night. But
deservedly so, I have to say.
Yes, indeed. But again, from a safety perspective, even, and especially when you're dealing with things that are relating to aerospace, because we have a disproportionate number of items that go kaboom. In fact, there's a running joke around the Mach 30 circles that rockets have exactly two modes of operation. One is varoom and one is kaboom. It is very important to maintain mode 1 operation. The bit that is important here as far as the open source documentation is document your mistakes, document your thought process, document your successes, document your build as you go. Coming full circle to your question, having the tools to document in a transparent way, transparent being document everything, don't hide anything, but also transparent from the standpoint of have the documentation tool transparent to the process. Now, what that looks like, I don't know. I'm in the process of trying to figure that out myself.
Well, I think I would be glad to. Let's keep talking about that as time goes on. We might be able to help figure something out there.
Well, that would be awesome.
Gentlemen, I'd like to bring us back to a couple other questions been drifting around the forum here, and we're coming up on about our last 20 minutes. But to address what the audience was asking, Mr. Dahlstrom has one of the questions saying, for aerospace, the U.S. has ITAR, EAR, etc. Are there similar restrictions in other countries, and can open source work better or better/or different in other countries?
I'll go ahead and take this one since I'm the export compliance officer for the company. Yes. First of all, other countries have their version of the restrictions. Some of them are more restrictive, some of them are less restrictive. They're all different. As far as and I get the sense that the question is centered around, can we pick and choose the country of origin? Can the servers be located, let's say in Paraguay? Yes, they can, but the information source came from you, and therefore is not only subject to the Paraguay law, for example, where the servers are, but also you are subject to export controls. So in other words, you've just doubled up on the number of regulations that you have to comply with. Yeah, I went there too.
Yeah, also, if somebody else, another country, which maybe doesn't have a restriction on sharing something, shares something, and then you learn about it, and your country has a restriction on sharing it, you're still restricted from sharing it. It doesn't matter that somebody else shared it in their country. If your country doesn't let you talk about it, you don't get to talk about it, even if you learned about it from somebody else.
Yep, it's called resharing, and there is a redistribution, and there is specific regulations about that.
All right. I have one other question for the panel myself. How can you take a company that has traditionally worked with closed methods, more traditional aerospace, and how would you effectively, in your knowledge and your vision, reform them to be able to use open source design, or how can that company itself pivot after so many years of operating in the old way to adopt to upcoming open source?
So I can give a first answer to that based on my very recent experience with my old company. One of the big aerospace four I used to work for about 8 years. I would say that the first step, if welcome, would be to open source within the company itself at first. I mean, firsthand, these companies have amazing amounts of talent that is, I'll be full disclosure, for the most part underutilized. There are organic efforts within those companies to bring about bottoms-up solutions to problems, innovation projects, innovation awards, innovation workshops, where people can essentially crowdsource-like address issues and problems that the company faces with any particular mission or product line. But I think a first viable step would be take a crowdsourcing paradigm that works, maybe it's open source software, and apply that across all branches of the company, especially from a technology and a development perspective. And I think that would actually benefit any company a lot. That would be a first good step. The second step is a bit more challenging, I think we can all imagine. But if company ABC were able to achieve that within themselves, then I believe the next step, which is open up the world, with some of the caveats that we talked about in terms of exportability and protection and access rights, I think will be easier and more culturally acceptable than going at it right off the bat. So first step, crowdsource internally.
Agreed. One of the companies that I did some work with had two different teams. One, they had literally the gentleman to the right or to the left of you in the cubicle farm would not know what you were doing. It was very, very compartmentalized, and when you released something, you released a document with it that told people how to connect to it. It wasn't a matter of, you get your specification had things, that were necessary, like the power requirements and so on. And this goes high, this goes low, this is an open drain type switching arrangement, or these are dry contacts. It specified it at a connection level, but the device itself was a black box, and there was exactly one person who knew exactly how that worked, and the likelihood is after 20 years, and probably before the damn thing flies, he's going to retire.
Right.
The other side of the house was, well, similar to, and this was years before Apple decided to do it with the Macintosh. They were flying the Jolly Roger. These guys would, like you said, Jason, share internally, and it was not called open source or open hardware or open anything. It was called bullpen engineering, because everybody would go in there, everybody had a say, and sometimes those discussions would be kind of heated, and hence the name bullpen. And until things were settled, or until everybody else cried uncle, you didn't go home. They if it went through dinner, they slid pizzas under the door, and things kept going. Those were the days. I'm dating myself. But the key here was that the open sharing of ideas generated much more usable product in both terms of service and in terms of documentation and serviceability of the device than the closed model. And I really, I really wish they would have stuck with the open model, but unfortunately, one of the key people passed away during one of the harder times, and they basically shut down that division, and McDonnell Douglas, and that was it. But the interesting thing, though, is the transition between open internally and open externally. There's a halfway point that you can use. You can open a design to a specific group. For example, have a group of vetted engineers that is semi-open and garner some of the benefit. And as time goes on, loosen that vetting process and loosen it a little bit more and a little bit more, obviously depending on export controls and so on.
Another thing I'd like to point out, which I hold quite dear to me for several reasons, but it's also a cultural advantage. I mean, I come from a generation, and we live in a world where information is just readily available. For first-hand experience going into a big company out of school, out of college, and being faced in an environment where it's very siloed, as Aaron was talking about with the first case, was kind of disheartening. And I think it takes away from just plain old good old innovation that even young engineers have. And so catering more to big picture, open information, open knowledge, and letting engineers, even less experienced engineers, be part of that, I think will benefit any company that undertakes such a paradigm in doing business.
Yep.
Let them wear hats. I
There.
recall my first couple days in Mojave and X-Core, as well as where I'm at now, was about just wearing multiple hats and taking on as many skills as you possibly could. And it was what invoked innovation, but it's also what invoked the drive towards learn as much as you can, so that you can have a diverse range of what you can contribute to and what you can understand as well.
Right, and when it comes to the open model, one of the biggest things is innovation. You know, everything else can go away, but the innovation that can happen with the open model is where the value is. The thing that you have to bear in mind is that when an industry has been siloed for so long, such as aerospace, those silos, the center of that silo is going to be very, very well studied. You're going to have PhDs where their specific focus is dead center or off to the left or off to the right, somewhere in that silo. But that's all they know. Once you get that rarefied, you really don't pay attention to the edge cases. But the edge cases is where those technologies come together. The integration and the innovation that is possible when you take things from silo A and things from silo B and you bridge that gap, there's usually something here, something that right in between them that that bears exploring, and that's where the soft underbelly of innovation is. That's where the ability to connect the two very well defined products or services happens, and that becomes a significant value add to the product.
I think that's where the creative people tend to live.
So to build off of that, the innovation is an awesome part of it, but the other, in a sense, the more definitional aspect of open source is the replication part. So when you open source something, everybody else gets it. And if they can use it for anything, then they will, which means that whatever that thing is, doesn't matter how unique or innovative or special snowflake it is, now everybody can have one, and they probably will if it's at all useful, which means that now it can become a foundational thing for the next innovation. Like, we have little satellites now using cell phone motherboards as their brains, because cell phone motherboards are really ubiquitous. Everybody, you can get them for cheap. So they're not like radiation hardened or anything, but it turns out they're okay, especially for the lifetime of a microsat. And so now, like, the cell phone thing, which used to be a brick that only rich people had, now is almost a commodity, and everybody has one, and now you can use it as a foundation for the next jumping off point. So the faster that happens, the faster technology diffuses and becomes assumed and foundational, then the faster you can build off of it. Like, everybody has a 2D printer. You just assume people are going to have a printer for paper stuff. You don't even like question it anymore. You don't ask, do you have a printer? You just assume even if they don't have one, they can get it printed. Someone else will have one. It's assumed. So, like, sooner or later, we'll have that for 3D printers, just like we have it for microwaves and coffee makers and everything. It'll just be, you'll assume that everybody has one or can get access to one. And then it becomes a foundation, and the next innovative thing is now poised to be able to happen. Whereas if you didn't have that technological foundation, you'd never have the chance to do the innovative thing. Like, Leonardo da Vinci invented bicycles way before he could even build a bicycle, because the foundation wasn't there.
Yeah, just to reiterate your point regarding everything's built on everything else, it was interesting that Sir Isaac Newton once said, "If I have seen further, it is by standing on the shoulders of giants." Even he, at the foundational point where he was making his developments, acknowledged that he was building on others, and we are doing the same.
My friend Brent is here off camera here, and he just pointed out a pretty good, closely related idea, which is it's similarly inspired. It's space is hard, so it's important that, for us to share information so that we all succeed and survive.
Yep, that's exactly it.
You know, crowdsourcing isn't really different from what we've been doing for the past 2,000 years, other than doing it with the internet.
Yep.
And much faster.
In fact, yeah, speaking of space being hard, I think I'm not going to use the language, not on something we're recording for posterity, but Elon Musk said it best.
Understood.
I don't remember what he said.
He said it's effing A hard.
That sounds like Elon. Kind of a closing question on our last 5 minutes here, but I wanted to ask about kind of a two-part question. We've spoken a little bit about historical examples of success and lessons learned from open source prior, but I'd like to ask about what are the future plans for open source in aerospace? What are the future plans that you guys are implementing in your endeavors, as well as what are the future plans other aerospace companies are implementing for open source? And second question is, who do you see as essentially the leader and the most progressive in terms of implementing open source as their business model in the aerospace industry?
I can take a stab and talk about what we're doing with open source. So crowdsourced technology is going to be core of our business model going forwards, and we're looking at that avenue as essentially our major avenue of R&D for space technology. And so we're focusing on 10-year and beyond space travel capabilities, and we're also focusing on probably 20-year and beyond economic activity development capabilities. And so we're looking for ideas that are TRL-1 to TRL-1, architectures, R&D projects, anything that has the potential of making a true difference in those categories of technology development. But beyond just technology, we have the very strong underpinning that crowdsourcing is not just applicable to technology, but it's also applicable in the sense of truly sourced market demand for anything we're trying to do in space in other industries. You know, my background, I'm Greek, as you can tell from my last name. I have a strong belief in democracy and giving anybody the chance to be part of something big. And I truly see crowdsourcing being the surface of something very transformative in our society. And a lot of people have talked about, you know, online-based democracy, and you know, everybody should be part of the political system and voting on everything. Let's not get ahead of ourselves. But if crowdsourcing is to work for aerospace, crowdsourcing is to work for technology, if crowdsourcing is to work for what we're trying to do in terms of market demand and sourcing demand, sourcing opinions, ratings, on anything to do with space, whether it's policy, regulation, technology, roadmap, strategy, destinations. You know, we care about what people, where they want to go, right? There's this constant strife between parties of Mars versus Moon versus asteroids versus everything else, which is kind of, excuse my French or slight French, you know, it's kind of silly. Democracy in its truest sense, in market forces in its truest sense, I think is the biggest power that we can experience as a species with crowdsourcing. And so that's the future I'm looking for, and I think it's going to help the space industry more than anything else. So.
Right,
I guess I could toss in some examples in our own situation. For one, the software that we have built our entire company on open source software, and the system we're running now would. I've told people earlier that it would take a team 5 years ago, even it would have taken a team of 20 people several years to develop what we've already got running, and you know, we've done it with a couple of people, and and as far as what we're working on, which I think is germane to this, is, we hope to provide, and we intend to provide, basically the information these companies need to talk to each other, to find out, who makes the widget that I need for my rocket, and who, then who am I going to sell my widgets to, and what's the technology for doing the thing that I'm trying to do. Those are all questions that we hope to be able to provide a platform for people to answer. So we're both an open source user and a facilitator, and we encourage anybody to participate in that wants to.
Yeah, I think you hit the nail on the head. Anybody who is an open source facilitator is by usually not going to be a user of closed source software. Obviously it started somewhere, but for example, we're 100% open source around here. I'm on a Linux machine talking to you. Dual screen workstation with all the capabilities and all the trimmings. In my other company, the network security appliance is Linux based, and has some neat little tricks up its sleeve. These are things that are possible because of open source. It's not because I am the best and brightest or anything else. It's because I knew where to look, and I knew whose stuff to copy and how to integrate it into one product. You were talking about the marketplace being able to take item A and widget A and service A and combine that into one thing that a person could develop a shopping list for their project. This is an awesome tool because it combines both scratching the itch, the needs, and the market where it can all be found. And the bottom line is that we need to be able to put it all together. Everybody's got a little bit of something. For example, most of the stuff I do is communications. My significant other does fabric engineering. Everything from circuits to the actual design of the fabrics to take load or distribute load. I do a little bit of computer works to support the communications. But the truth of the matter is, if it were possible for me to focus exclusively on communication, because I know somebody else has developed the other thing, or I can find out, that would speed my development immensely.
Yeah, just knowing who to ask about what you want to know.
Yep. And Google only gets you so far.
All right, gentlemen, I think that's pretty much all the time we have for this evening. Thank you very much for joining us. I've been Ethan Chu for the California International Spaceports Network. We've had Aaron Harper of Issyroo Farms, an open source expert, Mr. Matt Maier from Mach 30, advisor to the board, Mr. Jason Aspiotis of Crowd2Space, CEO and founder, and Mr. Gary Bickford of Integrated Space Analytics, CTO. Thank you very much, and good night.
Thank you.
Thank you. Good night.
Good night.